Hello. Hi, my name is Dr. Gloria Guerra, and I'm going to be working the Test 1 review for Math 1332. And hopefully this will aid you as you get ready to study for the exam. Okay, and so what I've done is I've printed a copy, my own copy of the test review, and the computer does generate different numbers for different uh, printouts, but the format is the same, and so just the numbers change. And so your printout may not have the exact same, for example, fractions and numbers that I have, here being shown on the paper, but that's okay. It probably has a similar format. And so I'm going to work these out for you. Okay. And so the first problem is this number 1 problem. So you see here, you've got a couple of fractions being subtracted here. And then this is actually a division sign divided by 5/7. Okay. So I'm going to write this down. Okay, and so I also have it listed. I'm looking here on my paper, and I also have the problem listed here. So sometimes I'll refer back to what I have on my other screen top because I've got another computer right in front of me as well. So I have 2 computers here that I'm working with. Okay, here we go. And so this is 1/2 minus 1/3 divided by 5/7. Okay, and so I'm thinking about the PEMDAS, which is the order of operations. Please excuse my dear Aunt Sally. And so I'm going to start by doing all the operations inside parentheses. So I'm going to start with the adding and subtracting, multiplying or dividing that goes on inside the parentheses. So operations inside parentheses. I'm going to write that down. Do operations inside. I'm going to just say grouping symbols, which include parentheses, brackets, curly braces, okay? And whenever you add or subtract fractions, you do have to find a common denominator. And so I'm going to use the work of multiples of my denominators, which are the bottom numbers. Okay, so I'm going to start with the bigger denominator first, which is 3, and then 2. And I'm going to find the LCD, which is equal to the LCM, okay? So 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12, okay? And I'm going to do the same thing for 2, and I'm going to look for a common multiple, the least common multiple. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. So you see how we have a common multiple right there with 6? That's the least common denominator, the least common multiple. Okay, so that's how we show our work to confirm what the least common denominator is for a fraction. Okay, now I'm going to build up my fractions. Okay, so I'm working with that 1/2, and I'm going to get ready to multiply and build it up. So I use this work. See, I want to ask myself, how many multiples of 2 do I need to get to 6? So you can count here, 1, 2, 3. So we need 3 multiples of 2 to obtain the LCD of 6, right? 1, 2, 3. So that's why I'm going to build this up and multiply this fraction by 3. And so then that will become 1 times 3 is 3, and 2 times 3 is 6. Okay, so 1/2 becomes 3/6. Okay, and then I'm going to subtract this 1/3. I'm also going to build up that fraction. I'm also going to say, well, how many multiples of 3 do I need to get to 6? I need 2. See, 1, 2. So we need 2 multiples of 3 to obtain the LCD of 6. So that's why I multiply this by 2. So 1 times 2 is 2, and I am subtracting because of the subtraction. and 3 times 2 is 6. All right. So now 1/2 minus 1/3 becomes 3/6 minus 2/6, and 3 minus 2 is 1, and you keep the common denominator of 6. So you keep this denominator, and you subtract 3 minus 2 is 1. So now this becomes 1/6 divided by 5/7. Okay. And the way we divide fractions is what we're supposed to do is we're supposed to keep the first fraction. You're supposed to change the division to multiplication, and you're supposed to flip, or you can say reciprocate, the second fraction. Okay, so 1/6 times 7/5. Okay, so keep, change, flip. That's how you divide a fraction. So you do not find a common denominator. Okay, so don't find an LCD. Don't find an LCD and LCM. We did that over here at the top because we were subtracting fractions. Whenever you add or subtract, that's when you do this work for multiples, but not here. To divide a fraction, you keep the first fraction, change the division into times, and then you reciprocate, you flip only the second fraction. And then the way you multiply a fraction is, for the most part, we multiply across. Okay, so you multiply like horizontally across. Okay, so this way. And then, and you do that in the numerator and in the denominator. So you multiply horizontally across in the numerators and in the denominators. Okay, and then after you do that, then you try to reduce the fraction, or you try to simplify the fraction, you know, if possible. Sometimes you can't reduce it anymore. You can't simplify it anymore. All right, so 1 times 7 is 7, and 6 times 5 is 30. Yeah, and that can't be reduced. Not a, there is no common divisor. 7, 35 is 30 more. Okay, so the answer for my problem that the computer generated is 7/30. Okay, so this is some of the work when you work on your tests. Yes, you can use the calculator as a tool, but you do have to show your work. If you only have an answer and no work to display, then I'm not going to give you the full credit for your work. So you have to show your work. Okay, and this is how you do that. If you want to go back and check, you could check, let's see, piecewise, if you wanted to check, because we're required to buy a TI-30X, so we could do the one ND key here divided by 2, and then let's see, plus, excuse me, subtract, because it's minus 1 ND key by 3, and let's see what that gives us here. That gives us 1/6, and see, we did get 1/6 here. Remember, we built up the fraction. 3 minus 2 was 1, so that does check that out correctly. And then now when I'm working 1/6 divided by 7, I have 1/6, then I'm going to divide it by the 5/7. Oops, let's see, 1 ND6 divided by 5 ND7. There you go. So I'm using this 1/6 divided by 5/7, and yep, that gives me 7/30. Okay, so you do have to show your work, okay, to get the full credit. Okay, all right, so that's number 1. Okay, let's go on to the next problem. Let's see. All right, so the next problem on my paper, this is it right here. we're using the order of operations to simplify this expression. So I'm going to, in the PEMDAS, please excuse my dear Aunt Sally, I'm gonna simplify the numerator, and then I'm gonna simplify the denominator. So in the numerator, this is a division right here. I'm gonna multiply this, then I'm gonna, let's see, well, let me write down the problem, but I know I can start with this multiplication for starters, okay? And then this down here, looks like they wrote down the problem again. All right. And that's supposed, I put down the answer so I can make sure I check my work. So we're supposed to end it with 4 when we're done. Okay, so let me write down that problem. This is number 2. So let's see. So we have negative 12 times negative 5 divided by 4 times negative 7. Yeah, and let me just put my glasses on. That's really small, even from here and here. And that's actually a plus sign, computer. Sorry. It's actually a plus sign. Yeah, and even on my printout, it's hard to see that there. I have a couple of printers, and the one I used to print this, it's not such a good ink quality. So that's why I have my computer up here so I can see the problem as well. It's a plus sign. Okay. Okay. All right. Okay, so I'm going to simplify the numerator, and then I'm going to simplify the denominator. And again, you know, when I'm thinking about order of operations, PEMDAS, please excuse my dear Aunt Sally, I don't have any operations inside parentheses. So that means, like, you know, I have a set of parentheses here, but there's no operation. Like, are you adding something? Are you multiplying something? Are you dividing? Like those 4 operations in math, adding, subtracting, multiplying, dividing. Do you have, you know, do you have any adding, or do you have any multiplying, or any division, or any of these operations going on inside the grouping symbols? And no, this is just negative 12 sitting here. This is just negative 5 sitting here. So we don't have any P. We also don't have any E. E stands for like any exponents. Do you have any perfect radicals, like perfect roots? You know, like the square root of 16 is 4, because 4 times 4 is 16. So do you have any absolute values? Like the absolute value of negative 6 is 6, for example. Do you have any of that going on? No. So no E. So then we get to the MD. And for that, whenever you multiply or divide, we're supposed to multiply or divide from left to right. So when we get to the MD, we're supposed to multiply, or we're supposed to divide, but only from left to right in the order in which they appear. Okay, so when I look at this, because I do have multiplication here, and I also have multiplication going on here. This is an addition sign. This is definitely last. See, AS stands for adding and subtracting. So that's definitely got to be last all the time, adding and subtracting in the PEMDAS. So we've got to focus then on this. This is multiplication from left to right, and this is also multiplication from left to right. So I'm going to focus on that. So negative 12 times negative 5, that should give us 60. A negative times a negative is a positive. Then you can always use your calculator to double check that. Negative 12 times negative 5, you see that's 60. Yeah. So we've got, this is equal to 60 plus, and then 4 times 7 is negative 28. And then it's all over. Again, if you want to check that, you know, 4 times negative 7 is negative 28. Okay, and then down here, this is what I call in 410 elementary algebra, subtraction of sign numbers. This is a sign number. So for this, we rewrite it as an addition problem. Keep, change, take the opposite. So this we keep, this we change to a times, excuse me, change to a plus, sorry. And then this you want to take the opposite. Okay, so 5 plus, and then the opposite of a -3 is a 3, okay? And so now on the bottom, 5 plus 3 is 8, and on the top, that's what I call rule number 2. You're adding sign numbers, two numbers with different signs, because see, this one's a positive and this one's a negative. So what you're supposed to do for that rule is you're supposed to ID your sign, and then you're supposed to subtract. So you see, when you're adding two numbers with different signs, they're competing. This one's a positive, this one's a negative. So you've got to decide, well, what sign do you go with, the positive or the negative? You're supposed to go, the rule says you're supposed to go with the one that's got the bigger distance, the bigger absolute value. So you see, the absolute value of 60 is 60. And the absolute value of -28 is 28. So you see, this one has the larger absolute value, which I call LAV. And when you backtrack, what was it to begin with? It was positive. So the sign's going to be positive. And then when you subtract, you're subtracting these two. You're subtracting 60 minus 28. This is the 10. Decrease that to 5. 10 minus 8 is 2. 5 minus 2 is 3. So you see, a 60 plus a -28 is a 32. Yeah, and then you can verify that here on your calculator. A 60 plus, and the negative is down here. See the sign changer? This is the sign changer. This is for subtraction. It's a -28, which is 32. So 32 divided by 8. And 32 divided by 8 is just 4. Yeah, 8 goes into 32 4 times. Okay? And that's correct. That is the answer that they're showing here you should get. Okay? All right. Okay, now for the next problem, number 3, let me just change my ink a little bit. All right, so this is the next problem here. -3, this is number 3, and this is the answer we're supposed to get when we're done. That's an improper fraction. And we could make it into a mixed number when we're done, but it doesn't require that. It doesn't say you have to make it into a mixed number. Okay, so when we look at this, it looks like we've got a couple of fractions being multiplied. That looks like a plus sign. And again, they wrote down the problem again, and I can't tell what that is here. Let me double check on my computer over here. This is supposed to be a division symbol here. That's a division symbol, and that's a plus sign. Okay, so let me rewrite that then. So number 3, we have -9/2, and in parentheses, 1/2 plus 3/4, and then that is a division by 5/6. Yeah, I'm gonna just double check that with my glasses. So when I printed the document, I left my document up so that I could still see that and use that. So yeah, I'm just making sure that's a plus sign, and then it is 3/4 divided by 5/6. Okay, just making sure. Small font. All right, so then as we're working this problem, okay, again, we're thinking about using the order of operations again. So in the PEMDAS, please excuse my dear Aunt Sally. We don't have any P. We don't have any operations, like we said over here, any operations inside the grouping symbols. So this is just the fraction 1/2 sitting here. So we're fine with that. And we don't have any exponents. We don't have any absolute values, no perfect roots. So we get to skip that. Again, it looks like we have multiplying and dividing going on. So you see here how you have multiplication, those fractions. And then over here, do you see how you have division? Yeah, so we're going to have to take care of both of those, multiplying and dividing, and we do that from left to right. So yeah, we'll do this first. So again, the way you multiply fractions is you just multiply straight across. Okay, you don't find a common denominator. Okay, you're multiplying fractions, so just multiply straight across. So -9 times 1 is -9, and 2 times 2 is 4. Okay, so that's -9 over 4. Okay, then over here, remember what we said. So I'm gonna put a plus sign, and over here I'm going to say this is 3/4 times 6 over 5. So remember we said earlier we're going to keep the first fraction, we're going to change the division into times, and then we're going to take the opposite of just the second fraction. Well, actually I should say, instead of take the opposite, I should say flip, excuse me, flip. So take reciprocal, So you flip it. So take reciprocal of the second fraction. Yeah. So the reciprocal of 5 over 6 is 6 over 5. Okay. And then again, the way you multiply fractions is we're going to just multiply straight across, and then we'll try to reduce that. Okay, so then I have -9/4 plus, this is 18, because 6 times 3 is 18, and 4 times 5 is 20. Okay, and then I'm going to go ahead and reduce that by 2, because I'm going to reduce since even numbers. 18 and 20 are even numbers. So if you have even numbers, you're safe by reducing by 2. And remember, even numbers, like how do you know those are even? Even numbers, they end in a 0, a 2, a 4, a 6, or an 8. So you see this ends in an 8, this ends in a 0. Okay, so then I have -9/4 plus half of 18 is 9. Okay, so that means 18 divided by 2 is 9, okay? Or you can do this, 18 divided by 2 is 9, right? Okay, or even here, 18 divided by 2 is 9, okay? And then half of 20 is 10, okay? And that can't be reduced anymore. That can't be reduced anymore. So now we have these fractions. And remember what we said about finding common denominators? We're going to use multiples and of our denominators, the bottom numbers. And I always start with the bigger denominator, which is 10, and then the 4. And we're looking for the LCD, which is the LCM. So 10 times 1 is 10. 10 times 2 is 20. 10 times 3 is 30. And I think we'll be okay with the 20. So I work with the 4. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. So you see how you have that match there? And also what you could do is you could repetitively add 4. So you have 4 plus another 4, which gives you 8, plus another 4, which gives you 12, plus another 4, which gives you 16, plus another 4c, which gives you 20. So you can always do that also, okay? And just write that out. And the LCD is 20. Okay, so then now when you build up your fractions, okay, so now we have -9/4 times, and you ask yourself, how many multiples of 4 did you need to get to 20? Okay, so you can count 1, 2, 3, 4, 5. See, 1, 2, 3, 4, 5. So these are going to be little 5s here. Okay, so I'm going to say here that we need 5 multiples of 4 to get to the LCD of 20. And so now when I multiply -9 times 5, that's -45. and 4 times 5 is 20. Okay, now I'm going to add and build the called this is called building up your fractions. So I'm building. So I'm going to write that down here that we need to. And you can see here 1 and 92 is. Okay, so let's see, I just lost the connection and I just reconnected is what happened. So I hope, I'm not sure how that's going to work with the video recording. Let me just make sure that it's still recording. Let me stop the share. It is still recording, okay. Let me share my screen. I can see this is spinning, so I'm not sure what's happening. Let's see. I'm not sure. This looks like it's very live. Okay, I'm not sure what was happening there. Sorry about that. But I hope that's recording though. Let's see. Yeah, I can see the screen sharing. I can see the recording button. So sorry about that. Let's see how that's going to. So so -45 plus 18, that's a rule number 2. The absolute value of -45 is 45. And the absolute value of 18 is 18. So you can see this one's much bigger. And when you backtrack, it was negative to begin with. So that means this is going to be negative, and it's over 20. And then I'm gonna have to subtract 45. So I'm making negative 45 plus 18. You can see that's a negative 27. Okay, and that this is a improper. This is an improper fraction. And as long as it's reduced, nothing else will go into 20 and 27. That's acceptable. And also on the answer, you know, they don't say that it had to be a mixed number. And so since they didn't specify, that should be acceptable. Now, if you wanted to make it a mixed number, you could, and you have to do long division. So I can show you that on the next page. If you wanted to make that negative 27 over 20, if you wanted to make that into a mixed number, you'd have to, a mixed number looks like this. So you'd have to do long division. One is 20, and then you subtract 27 minus 20 is 7. That's your R. That's your remainder. And then this gets recorded like this, clockwise. So this is negative 1, and then remainder is 7 over 20. There you go. That's a mixed number. And this is improper, where the 27, the top number, just not looking at the negative, but 27 is bigger than the bottom number. That makes it an improper fraction. And improper can be made into mixed numbers by doing long division. Okay, so that's 3. Okay, let me change up my ink again, and let's do number 4 now. Let's see. Okay. Okay, so 4, we're being asked to simplify this, and this is the absolute value of negative 75. Okay, that's absolute value. So remember what absolute value does? Absolute value measures distance on a number line. From 0. So if you wanted a picture of this, here's the number line. Let's say here's 0. Let's say negative 75 is somewhere over here. And let's say this is you with a measuring tape. And you know, nobody's measuring tape has even a ruler. I have a ruler right here. Nobody's measuring tapes or rulers have negative numbers on them, because when you're measuring distance, distance is north, south, right? East, west. It's like you're moving in the west direction, you're moving in the negative direction, but you're measuring distance and units of length. So when you're starting off at 0, from 0 negative 75, you see how many units of length do you have? That's just 75 units of length. Yeah, so the absolute value of negative 75 is just 75, okay? Now, if we had something like this, a negative absolute value of negative 75, if we had something like that, then this little guy here means take the opposite. Take the opposite of this. This also means it's like an imaginary -1, which will change the answer's sign. So you see, what's the opposite of this? Well, you already know that absolute value negative 75 is 75. So now we say, okay, what's the opposite of 75? The opposite of 75 is a negative 75. So the only way that absolute value could be negative is if you have a negative outside. But otherwise, the absolute value negative 75, that's 75. And also if you had this, the absolute value 75, that's 75. But if you had something like this with a negative out here, then that makes it this. Okay, so that's 4. Okay, let's look at 5. Okay, so close absolute value. And then you can see that here is where I'm getting that from. Okay, so here, one of the last things you're going to do is you're going to do 4 times something, right? That's one of the last things you're going to do. First thing you want to start off doing is finding out inside, what are you trying to take the absolute values? So you're trying to find out this mystery. What are you trying to take the absolute value of? So what is this here? So when you think about, the inside of what's inside these absolute values, I'm seeing I have parentheses here. So what comes to mind is the idea of PEMDAS. Please excuse my dear Aunt Sally. And I see that I have to do this P. What's the operation inside that grouping symbol here? So what is this? Okay, so I'll start with keep, change, take the opposite. So 7 minus 22 is 7 plus negative 22. So keep, change the subtraction to plus, and then take the opposite. And then that's sign numbers. So you have to decide, well, what's your sign, and then subtract. So the sign you're going to go with is a negative, because the 22, when you take the absolute value of negative 22, that's bigger absolute value distance than 7. So you see this one's bigger than this. So this is the larger absolute value. So when you backtrack, see how it's negative? So here your signs are competing, a negative, positive, go with the negative. And then when you subtract 22 minus 7, so make this a 12, and this is 1 to 7, 8, 9, 10, 11, 12. Looks like that's 15. Okay, so it's going to be, this is a negative 15. So now when you rewrite this, you have 4 times this absolute value of 9 minus, and now you know this is here a negative 15. And then again, keep, change, take the opposite. So that's going to happen here. Keep, change the subtraction to plus, and then take the opposite. So 4 absolute value, 9 plus, and the opposite value of negative 15 is a positive 15. Okay, you probably also heard that 2 negatives like that side by side make a positive. So now this is 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. If you don't make a mistake, you can also add 9 plus 15 is 24. Okay, so now we have 4 times the absolute value of 24. And the absolute value of 24 is 24. So this is now 4 times 24. Okay, so 4 times 4 is 16, carry a 1, 4 is an 8, 9, okay, 96, right? So that's number 5, which is 96, and that's correct. All right, let's continue with number 6. So it says evaluate the algebraic expression for the given value of the variable. Okay, so I have negative x squared minus 6x, and that looks like a semicolon there. X equals negative 3. Okay. That's what it looks like on my paper here. The negative 3 everywhere, and x exists. So everywhere you have an x, you're going to replace that x with a -3. Okay, so I have a negative here. I'm going to put parentheses so I can show I'm substituting the -3, and then it's quantity squared minus 6 times x, so parentheses -3. Okay, and when you think about the PEMDAS, again, please excuse my dear Aunt Sally. We're going to do these exponents here. This exponent, and because we already know that we have -3 inside, so we don't have to simplify that anymore. If we didn't know it was -3 and we had a lot of operations, then you'd have to figure out what are you squaring, but we already know this is -3. We're squaring -3. This is a squared second power. So this means -3 times -3, and then you've got this imaginary -1 here. And so basically 3 times 3 is a 9, and then if you count your negatives, you have 1, 2, 3. You have an odd amount of negative signs. So an odd amount of negative signs should give you a negative answer. If you had an even amount of negative signs, that would give you positive answer. We have a negative amount, an odd amount, so it gives us a negative answer. Yeah, so, and even if you take them like 2 at a time, like -3 times -3 is 9, and then 9 times -1 is -9. So yeah, we do get a negative answer. Okay, so now this is -9, and then over here minus, and then when we figure this out over here, we did the exponent, and now we're going to do like this multiplication. We don't have any division. We do this multiplication right here. 6 times negative is we're subtracting sign numbers. So when you're subtracting sign numbers, you want to take the opposite. You want to rewrite the problem and make it an addition problem. So I have -9 plus 18, and that's just going to give me 9. So again, I'm adding two numbers with different signs. I want to keep the sign of the number that's got the bigger distance, and then I'm subtracting 18 minus 9 is 9. Okay, so number 6 is, that's giving me number for that number there. Okay, so I've got 2 in parentheses, 2y minus 3 close parentheses, take away parentheses, 3y plus 5. All right, so I see distributive property here. Okay, this is distributive property. Okay, this is like an imaginary -1 right here. And this is also more distributive property. So I'm going to say do the distributive properties. Yeah, so remember that when you're multiplying or when you're dividing two numbers at a time, remember that um, when multiplying or dividing two numbers at a time, remember, same signs give you positive results. Like a negative times a negative is a positive. Whereas if you have different signs, one positive, one negative, different signs give you negative results. So same signs, positive results, different signs, negative results. So when I think about that, 2 times 2y, those are two positive, those are the same signs. That's going to give me 4y. 2 times, see this negative 3? That's different signs. Different signs gives me a negative result, so it's negative 6. Negative 1 times 3y, okay, those are different signs, give me negative result, that's a negative 3y. And then negative times a positive, those are different signs, that gives me a negative result. Okay, so same signs, positive, different signs, negative, okay? And now when I regroup, I'm going to regroup all my y's, so 4y I'm going to regroup all my constants, negative 6 minus 5. Y, that's just one y, and the computer will just want you to record y. One y is y. And then here I've got a negative 6 minus 5, which is a negative 6 plus a negative 5. Okay, so keep, change, take the opposite. So negative 6 plus negative 5. And that gives me a negative 11. Okay, so the computer doesn't like it when you write this, even though it's equivalent, y plus negative 11. It really prefers this y minus 11 because less is more. So you owe somebody $6, you also owe somebody $5. So in the accounting books, you still keep that little negative. So keep that little negative, that you're still owing that. So you owe an $11 now. So this says that uh, you, you basically add and you basically keep the negative sign. Okay, so number 7 should be y minus 11. Okay, now we're going to go to the next problem, which I think is number 8. Each of your problem like this on the test, what is your greatest common divisor? So you're dividing it by some greatest, I'm going to call it a GCD, which stands for greatest common divisor. So communicate that with your instructor, what you're using, okay? And I believe here, I believe 7 will work. They're not, if they were both even numbers, then I would have tried 2, but this is not an even number. It has to end in a 0, 2, 4, 6, or 8. This 49 is not an even number. I know 42 is, but that's why 2 won't work. And I jumped to 7 because I don't think 3 will work. If you try to divide by 3, 42 divided by 3 is 14, but it has to be the same common divisor has to divide into both the numerator and denominator evenly with a remainder of 0. So you see how you got these decimals that repeating? This is a decimal. That's how I know that 3 doesn't go into 49 evenly. Okay, and 5 doesn't work either because in order to use 5, these should either end in a 0 or a 5, and they don't. So that's why I jumped to 7. So I usually try to exhaust when I try to reduce. So I usually when I try to reduce, when I reduce, I try using um, prime numbers, like I tried 2, I tried 3, I tried 5, I tried 7, I tried 11, 13. let's see, and maybe 17 and 19. Yeah, but usually if something can be reduced, usually you'll find it within those first lists of prime numbers. And here it was, I'm going to try 7. So 42 divided by 7 is 6. And then 49. Okay. Now, you need to communicate with your instructor what your common divisor is. And if I use the calculator as a tool, let me go back to that. Let's see if I did 42 and then ND and then 49, hit enter. It does reduce that for me as 6, 7. So you can check your work, but I do want you to identify what the greatest common divisor is. Yeah, because otherwise you're just typing and checking and typing and not really the knowledge of what are you thinking, what's the greatest common factor. So I do want you to think that out on paper there by communicating that. Okay, and then on number 9, they want you to find the product and then write it in lowest terms. So product is another word for multiplication. So you have 12 over 5 times 7 over 8, okay? So remember what we said about multiplying? You can multiply straight across and then just reduce, okay? So 12 times 7 is 84. And then 8 times 5 or 5 times 8 is 40. Okay, and then you just want to reduce that out. So you can reduce, you're safe by by a lot of twos, and you might be 42, and then 40 divided by 2, that gives me 20. These are again even numbers, so I'm going to reduce that again by 2. So 42 divided by 2, like what's half of 42? 21. And 20 divided by 2, what's half of 20? 10. Yeah, and then I don't think that can be reduced again. What's a common number between 21 and 10? Yes, I know 3 and 7 will go into 10 evenly. 3 times 7 is 21, but 3 and 7 will not go into 10 evenly. So I believe we're done with the uh, lowest fraction there. And again, that's an improper fraction. 21 is bigger than 10. So if you wanted to make it a mixed number, it doesn't say you have to in your instructions, but if you wanted to, and as long as that palette, as long as this comes up in the palette, then you would be allowed to make that into a mixed number. So 21 divided by 10, 10 times 2 is 20, 21 minus 20 is 1. That's your R, your remainder. And it goes like this clockwise. So this is your whole number, 2 quotient. Your remainder is 1, and the denominator is 10. Okay. And then now, also looking back, remember we were thinking about using 4. Well, now that we've done reduce this by 2 and 2, 2 times 2 is 4. So I also could have reduced it by 4. 84 over 40 could have shown I was reducing it by 4. If anybody was thinking that, 84 divided by 4 is 21. 40 divided by 4 is 10. Which is what we got when we used 2 and then 2 again. Okay. Okay, now I'm going to look at number 10. So 10, I'm working with perform the division. So 4 nines divided by 3 sevens. That would be this one here. 4 nines divided by 7/3. 4 nines divided by 7/3. Yeah. Okay. All right. All right. So when we're dividing fractions, we're going to have to keep the 4 nines. Going to have to change the division to multiplication. And then we're going to have to take the reciprocal of just the second fraction, not the first one, just the second one. So when I reciprocate 7/3, that is 3/7. Okay, and then I'm going to just multiply straight across. 4 times 3 is 12. 9 times 7 is 63. And if you want to check that, 9 times 7, just to make sure on your nines, yeah, 63. And then to see if you can reduce that, it might be that maybe 3 might work. 2 wouldn't work because this is not an even number. Doesn't end in a 0, 2, 4, 6, or 8. But maybe 3 will work. So the way to test that is, let's see, let's do 12 divided by 3. Excuse me. Awesome, that works. And then 63 divided by 3. Yep, 21. Yep. And I don't think that can be reduced again. Like there's not remember, these are called greatest common divisors. So you want to communicate that with your instructor, okay? Your greatest common divisor, you want to communicate that with your instructor, okay? Greatest common divisor. Okay. All right, so let's go to 11. Okay, so we're subtracting 7/12 minus 4/9. Okay. Okay, so you can see that on my paper here to my printout. Excuse me. Okay, so I need to find common denominators. So I'm going to use multiples of my denominators. I'm going to go with the biggest denominator, which is 12, and then with 9. So 12 times 1 is 12. 12 times 2 is 24. Remember, you can also keep repeating, add 12 and then plus 12, see? And then plus 12 again, see, 36. And I think I'm going to stop there because I think we're going to find that now if I look now at the nines. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. So if you want to check that, you can do 9 plus 9. See, that's 18. And then plus another 9. See, it's 27. Plus another 9 is 36. See how that works? So just make sure you don't make a mistake on that. 9, 18, 27, 36. And then you can see this common match. Okay, now we're going to build up the fractions. So on the 7/12s, I'm going to show how I'm multiplying it, and I'm going to ask myself, okay, how many multiples of 12 are needed? So you can go back and check. 1, 2, 3. 3. So these are going to be little 3s. So you go back and ask yourself how many, like for this denominator that's 12, you go back many multiples of 12 that we need before we got, so 12 times, and 12 times 3 is 36. And then notice how you're subtracting, and then you're going to take the 4 nines and you're going to build that up. So then you're going to similarly ask how many multiples of 9 are needed. So 1, 2, 3, 4. See, 1, 2, 3, 4. So it's 4. So these are going to be little 4s here. And this is called building up the fractions. Okay, so you have to find a common denominator whenever you're adding and subtracting, and you should use multiples. That's the easiest method. And then you build up your fractions, okay? And then, so this is minus 4 times 4 is 16, and 9 times 4 is 36. Okay, and then 21 minus 16, so I'm going to use my fingers, 16, 17, 18, 19, 20, 21. So it looks like it's 5 over 36. And that can't be reduced anymore. That should be lowest terms there. Okay. And again, use it as a tool and then to check your work, but you do have to show your work. But to check that, if I say 7 ND 12, and then I take away 4 ND 9, I do get the 5 over 36. So you are able to check your work. It's just for the full credit, you do have to show your work. Show me how you're building up. Show me how you're building up your fractions. Show me how you're finding a common denominator, and then you have your answer there. Okay. Sometimes in schools, like elementary school, they teach, instead of teaching the multiples, they just teach they find a common multiple, not the least common denominator, not the least common multiple, but they find a common multiple. And sometimes they just say, oh, just do 12 times 9. But when you do 12 times 9, 9 times 2 is 18, carry a 1. 9 times 1 is 9, plus 1 is 10. This is a common denominator. This is a common denominator, but it's not the least. See, the least is 36. See how much smaller the numbers are? So when you just do 12 times 9, that's a common denominator. Then you have to build it up. Like, how many 12s do you need to get to 108? So like, wow, how many 12s do I need to get to 108? So 108 divided by 12. Well, I need 9 of them. 9 of them. So then here you would be doing 7 times 9 over 12 times 9. 7 times 9. 7 times 9 is 63, and then remember 12 times 9 should get me back to the 108. And then how many 9s do we need to get to 108? So this is 108 divided by 12. That gave me the 9s. And then 108 divided by 9, that gives me 12. So I need 12 of them. Yeah. So then come over here, and 4 9s, and these are times 12, which gives you big numbers, because 4 times 12 is 48, 9 times 12 is 108, and then 63 minus 48, 63 minus 48 is 15 over 108. Yeah, but then now you have to reduce that. See, we know we're going to get 536. If I knowing that, if I work backwards knowing that, the greatest common divisor looks like I would use 3, because 3 goes into 15. See, 5 times. And let's see how many 108s go into that. 3. How many 3s go into 108? See, 36. So the process is similar, building up the fractions, subtracting, reducing, all that's similar. It's just you got a bigger numbers because you just went with a common denominator and not the least common denominator. Okay, but we still end up with the same answer, 5 over 36, but you'd have to show your work for that. Okay. Okay, let's go to number 12. So 12 says insert either the less than or greater than between the given pair of integers to make a true statement. So you've got negative 20 and you're comparing that with negative 1. So, and your choices are to use either the less than, the greater than, or the equal to statement. Okay. And actually they didn't say the equal to, they just said insert less than or greater than between the numbers. Okay. So this is the symbol for less than. And when you compare these numbers, we always compare, you always compare from left to right. So you're saying this number is what in comparison to that number. So you always compare from left to right. So in our case, negative 20, if I look at a number line, and I say here's 0, so negative 1 would be about right here. And then negative 20 would be like somewhere way out here. Okay, but on the negative side of a number line, on the negative side of a number line, the farther away a number is from 0, then the smaller it is. So when on the negative, just looking at the negative side of the number line, the farther away a number is from 0, then the smaller it is. So you can see on this side, on the number line, this negative 20 is farther away from 0 than negative 1. That means this is smaller. This one is smaller. That means this one is larger. So when we compare this, negative 20 what is what in comparison to negative 1? Because we've got to compare from left to right. So negative 20 is less than negative 1. Okay, and this is the symbol for less than. Okay, and a cute way of remembering that is you know, with gaming and Pac-Man. You can draw Pac-Man around that. Pac-Man always wants to consume the larger number. So we think about constructing a Pac-Man. See how he's chomping here? Okay, so in gaming, we want larger values, right? Like to win, right? That's how you win. The more values, the more points you have. So this Pac-Man also wants to consume the larger number. Students forget, oh, which one, what does this mean? What does that mean? They forget. They might go blank on a test. So that's a cute way of drawing that up to remember that. So this is drawn with this idea here so that he eats, Pac-Man eats, consumes the larger number. Okay. Okay, now let's look at 13. Simplify the algebraic expression. So we have 15x plus a negative 8y plus a negative 2x plus 11y. Okay. Yeah, and I've got that here. You can see that also there. Simplify the algebraic expression. Okay. So we want to alphabetize them. X's will go first and then Y. So we're going to alphabetize the variables. And I'm also going to, regroup the terms. And if I start with the X's, and I like to stack them. I'm going to stack them. So if I look at the X's, I've got 15x plus negative 2x. And then if I look at my Y's, and if I change my ink a bit, on my Y's, I've got a negative 8y and an 11y there. Okay. And both of these are using rule number 2, which in elementary algebra 410 we teach that you're adding two numbers with different signs. So when you're adding two numbers with different signs, they're competing for their signs, you're going to have to ID your sign. You're going to have to make a decision, like, do I go with the positive or do I go with the negative? Do I go with the positive or do I go with the negative? You have to decide on your signs. And then the rule says, you do have to subtract. Yeah, even though you've got, an addition, the rule says when you're adding two numbers with different signs, you do have to subtract. That's the rule. And you have to identify your sign, the one that has the bigger absolute value. So here, this one's going to be a positive because 15 is bigger. Here, this is also going to be a positive because 11 is bigger. Yeah. And then you're going to subtract. Okay. So here, the absolute value of 15x is 15x. The absolute value of negative 2x is 2x. This one has the larger absolute value, and you backtrack, it's positive. So it's going to be positive, and then 15x minus 2x is 13x. So this is 13x. And then over here, the absolute value of negative 8y is 8y. And the absolute value of 11y is 11y. This one has the bigger absolute value, and you backtrack, it was positive to begin with. So it's going to be positive. And then 11y minus 8y is 3y. Okay. So then our answer, when I alphabetize them, x's go first, and then the y's. So that one should be on 13, that should just be 13x plus 3y. And you cannot combine that further. Like, please don't try and say that's 16 or 16xy. That's not correct. These are unlike terms, and you don't have permission to further combine them. It's like they say apples and oranges, water and oil. You cannot further combine them. Okay. So they're unlike terms. In order for you to combine them, you'd have to have the same letter and the same exponent. So if you had 13x plus 3x, then you could say, oh, that's 16x. Or if they had the same y's, 13y plus 3y, then you could combine that. So if you had 13x plus 3x, then that would be 16x. Or if you had 13y plus 3y, then you could say that's 16y. Then you could do that, but you don't, so you're going to have to stop here, unlike terms. Okay. Okay, let's look at 14 now. Okay, so for 14, we have perform the indicated division or state that the expression is undefined. Okay, and I've got 12 over 0. Yeah, and that is undefined. Yeah, and math, we cannot divide by 0. It's not allowed. And this can also be written like this. That's saying the same thing. This can also be written in the house. The numerator, the top number goes inside the house, okay, like that, okay. And also, if you want a cute way of memorizing that, does it spell on or does it spell no? So the way we do that is that this is a number, so N for a number, and the zeros can represent the letter O. So this spells no, no. So no, you cannot compute that, okay? Whereas if you look at 15, it says perform the indicated division or state the expression is undefined. On that one, they have 0 divided by a negative 15. That one is 0. Okay, so this can be written this way also, 0 divided by negative 15, or 0 divided by negative 15. Okay, and so this would give us 0. So usually with division, you want to break them up into groups. Like example, if I had 6 divided by 3, y'all know 6 divided by 3 is 2. So the idea is that, let's say you have 6 beads, 1, 2, 3, 4, 5, 6 beads, and you want to say how many groups of 3, right? So how many groups of 3? So how many groups of 3 can we make? And you would say, okay, 2, right? So that's why over here this is undefined, because in order to do your division and you look at your denominator, you want to say how many groups of, like in this example, 3. We wouldn't bother doing division if we couldn't, if you can't say how many groups of 0 can we make, right? In this case, this is undefined. We need to have at least a group of 1, right? How many groups of 3 can we make? Okay, and over here, this is 0 divided by negative 15, okay? And if I show you on the calculator also what the calculator does, 12 divided by 0, you'll see it doesn't say undefined though. You'd have to know that. And usually, like on this problem, it does have multiple choice expressions undefined. Sometimes it's open-ended, and you'll have to remember the word undefined. This says dividing by 0 error, okay? Whereas if I do the other one, 0 divided by negative 15, that gives me 0, okay? So, and also on the, what does that spell? That spells on. The 0 stands for the letter O, and negative 15 is a number. So see that this one spells on, like right on. Okay, we can compute that one. That would just be 0. This one spells no. You cannot compute that long division problem, so that's undefined. Okay. Okay, so that was 15. Okay, now let's look at 16. So determine whether the given number is a solution of the equation. Negative 3y plus 22 equals negative 6y plus 13. And looks like we're testing negative 2. Okay. All right, so we want to do some substitution. Determine whether the given number is a solution. So we actually want to substitute. Okay, so everywhere you have a y, you want to sub a negative 2, substitute a negative 2. So this is negative 3 times y. So negative 3 times negative 2 plus 22. And put a question mark here because we want to know if that equals negative 6 times y, negative 6 times negative 2 plus 13. Okay, so a negative times a negative is a positive. This is a positive 6. 6 plus 22 which 6 and 2 is 8. That looks like that gives us 28. Okay. And over here, negative times a negative is a positive 12 plus 13. Okay, and 12 and 13, 3 and 2 is 5, 1 and 1 is 2. So it looks like that's 25. Oh, so then this looks like this is false. Negative, I'm sorry, 28. 28 doesn't equal 25. And so to answer the question, determine whether the given number is a solution, we're going to say no. No. Negative 2 is not a solution to this equation. And remember what the equation was. Negative 3y plus 22 equals negative 6y plus 13. Okay, so that's no. Okay, now we're going to look at 17. Okay, so 17 says, express the sentence as a single numerical expression. Then use the order of operations to simplify the expression. Okay, so they have the words or the phrases, subtract 10 from 7. And then they want us to multiply this difference by 2, okay. Oh, and then they want us to square this product. Okay. Okay, so this is vocabulary here. Subtract from. So there are some words in math that require you to subtract in the reverse order, and this is one of them, and it comes from the words subtracted from. I know it just says subtract from, but that stems from the subtracted from ed. So subtracted from cause for us to reverse the terms. So you want to subtract the terms in a reverse order. So I'm going to say you want to subtract the terms in a reverse order. Reverse the terms. So subtract the terms in a reverse order. So we are going to use subtraction, but instead of putting 10 first, you're going to put 10 last and then 7. Okay. So you're subtracting these terms. You're subtracting the 10 from the 7. And then you're going to multiply this difference. So this is a difference. Multiply that difference by 2. So then that means that I have to do this now. Okay. So that's related to this. And then now they say multiply this difference by 2. So it's talking about this now. And then now the last thing we have to do is square this product. Square this product. Okay, so product is something you get when you multiply. So 2 times this. But then they want you to square that product. Okay, and then I can see here that this is like a little multiple choice option here. Yeah, so let's see if I'm looking at mine. Yeah, on mine it looks like the best choice is the first one. Choice. Yeah, and then you can see all my choices here. but I do it on paper, then I look for the one that's closest to the match, and it does look like this first one is the better match there. And then and everybody has different numbers on their packets, and then they could be in different choices, A, B, C, D, E. But just for looking at this, and then we're not done yet, because then after you do that, they want you to use the order of operations to simplify the expression. So then they actually want us to figure what that is. So again, the last thing you want to do is like take this value and square it. That's the last thing you want to do. You need to first figure out what are we scoring, like what's this mystery quantity in here. So when I think about PEMDAS, P doing operations inside parentheses, I need to take care of this here. So if I have 7, I can't give somebody 10. I'm going to be shy. I'm going to be short. It's going to be a -3. This is 7 plus a -10. And I'm going to have to go with a negative. You have to decide on your sign. I'm going to have to subtract. So 10 minus 7 is 3. So now I have 2 parentheses -3 quantity squared. So now 2 times -3, that's a -6 quantity squared. Now I know what that mystery value inside is. It's a -6. So now I can do -6 times -6, which for this problem, number 17, the answer is 36. Okay, I'm going to go to 18. So 18 says, solve the equation -3y minus 12 equals -6. Solve the equation using both the addition property of equality and the multiplication property of equality, and then check the proposed solution. Okay, so here, when you're solving the equation, they say to use the addition property of equality. So that means like you want to isolate this variable y, and you want to move this term. So the opposite of a -12 is a +12. So I'm gonna move this term over here by adding its opposite. So that's what they say, using the addition property of equality. So this is using the addition property of equality. Okay, so I'm adding 12 to both sides. And then this cancels out. These are called additive inverses, because a number plus its opposite zeroes out. So a -12 plus a 12, that's a number, and then its opposite, those zero out. So those disappear. So all you have is -3y equals, and then when you add these up, again, you want to ID your sign, and you want to subtract. Okay, so you're going to go with a positive because the distance at 12 is bigger. Absolute value of -6 is 6. Absolute value of 12 is 12. So you can see this one has a larger absolute value. And then when you backtrack for that 12, when you backtrack, it's a positive number. So this is positive, and 12 minus 6 is 6. It's +6. And then it says using both the addition principle and also the multiplication principle, the multiplication property of equality. So now, and they say multiplication property, but it can also be called division property of equality. So in math, undo times side. So I'll do that here and then here. And then these fall out, so you have y equals. And then 6 divided by negative 3, 3 goes into 6 twice. Okay, so it looks like that's going to be a negative 2 because different signs produce negative results. So if I look at 18, that's showing a negative 2. Okay. Okay, then if I look at 19, that's also solving the equation. Change my ink. Okay, so here I'm going to use the addition properties first. And property, let's see. And I'm going to have to use the addition property twice. So I see that I have x's on both sides and constants on both sides. So usually teachers will put all the variables on the left-hand side and all the constants on the right-hand side. So usually our move is to set it up like this, to move things in such a way using opposites so that you have all the variables on this side of the equal sign and then all the constants on this side of the equal sign. So I'm going to start by moving this over here. So the opposite of 24 is a negative 24. Yeah, and it's just with respect to x, okay? And then these fall out. And then remember, there's always like a little plus sign here that you don't see. So you're adding two numbers with different signs. So you're going to have to ID your sign, and you're going to have to subtract. So you want to go with a negative because, see, negative, the absolute value of 3x is 3x. And the absolute value of negative 24x is 24x. So you see, this is much bigger. This is a larger absolute value. And you backtrack, see how it's negative? So this is a negative. And then when you subtract 24x minus 3x, 4 minus 1 is 4 minus 3 is 1. So it looks like it'd be a negative 21x when you move this over here and you add these two. And then I'll just recopy minus 5 equals 2. And now I'm going to move this over here. So I have to use opposite. So opposite of minus is a positive. And then that's the only way that get 0 out. Then you have negative 21 and undo is